Okay, so we're going to do mapping and landforms. Let's see if I can move this. I can. Okay, up at the top it says topography refers to the shape of the Earth's surface, and specifically it's showing you relief, which is a change in elevation. Flatland is considered low relief because the change in elevation is low. Mountains are high relief because the change in elevation is high. Okay, landscapes or landforms are the physical features of the Earth. The three main types: mountains rise up very high, they have a summit and a peak. Plains are flat, you have coastal plains, and then you have grasslands, and then plateaus, which rise up about 600 meters, and then they are flat on the top. Now, Virginia, since you will be learning specifically about Virginia's topography, has all three of those. All right, so elevation is defined as the height above sea level. Remember, as you're going through this, to pause it whenever you need to write down notes. Okay, so elevation is the height above sea level, and because we are at the coast, we are about at sea level, slightly above, but generally at sea level. It shows you the landform regions in the whole United States, and you can see how Virginia ends up with all of them. Okay, I think you know what a mountain is. Maybe the most important thing here is to know that the tops are called summits and the sides are called slopes. And you get the height of it as in the height above sea level. So a mountain that is really inland, for example, the one in the example listed at the bottom in Colorado, is sitting on a continent. So you're going to still have to count the continent. It's not going to literally be, here's the mountain and the person standing right here. It's not going to be like that because the continent is here underneath that mountain and the sea level is down here. So it's going to end up being sea level all the way up. That's what that means. Okay, a range, it says a roughly parallel series of mountains that have the same shape and structure. Generally, they're all formed at the same time. A mountain system is a group of ranges, and a mountain belt is a group of systems. So we started from smallest to biggest there. I'm not going to ask you to know the Circum-Pacific and Eurasian Melanesian. I'm just going to let you know that there are two major mountain belts on the Earth. Let's skip that. Okay, plains are the flat areas that do not rise far above sea level. We already said this. They have a low relief. Two types: coastal plains, which is where we live. It says it's along the coast. Lots of farming due to the enriched soil. Interior plains, like the grasslands, they are much higher above sea level. They do have good farming soil, and they are good areas for raising cattle. A plateau rises up 600 meters or more above sea level, and then it has a flat, generally flat top. Many are located in the dry desert areas. You can see in the picture, this is probably New Mexico, Nevada, Arizona area. Okay, a map is a drawing of the Earth on a flat surface, which makes it really difficult because you're taking something that is three-dimensional and putting it on a flat area. So a globe is going to be your most accurate representation. A scale is what we use to compare the distance on the map or the globe to the actual distance. In your example, 1 centimeter equals 10 kilometers. When you look at any map or globe, it's important to first check the scale so that if it's asking you how much distance is between two areas on the map, you know what your inches or your centimeters equate to. We're going to practice that in class. Okay, longitude are also called meridians. They run north and south, but they measure east and west. In other words, if I'm on one of the longitudinal lines and I'm moving to another one, I'm either going east or west as I travel between them. Each one is measured in 15 degrees of longitude. They go from 0 to 180. Okay, the prime meridian, this is a famous longitudinal line that you should know. It's 0 degrees. It runs through Greenwich, England. It's spelled Greenwich, but you pronounce it Greenwich. Okay, and a lot of times in the SOL, they expect you to just know where the prime meridian is, so you would look up Greenwich, England, and you would know it was there. Time zones, you don't really need to know them by heart. There are 24 hours in a day. Every 15 degrees equals an hour, so we have 24 time zones. 24 lines of longitude matching up to those hours. Okay, the International Dateline is also another famous longitudinal line. It's the 180th meridian. If you pass the line going east, you take away a day, and if you pass it going west, you add a day. Okay, latitude are also called parallels. They cross the meridians at right angles. They are drawn east to west, but they measure north and south. Again, picture yourself. If you're on a latitudinal line and you're going from one to the next, you're going to be traveling north or south. They go 0 to 90 degrees. 0 degrees is the equator, and 90 degrees is going to be your north and south poles. Okay. Cartography is the science of map making. And we're going to look at different types of maps, okay? The first one is your topographic maps. This shows you your change in elevation. It shows mountains, rivers, forests, depressions, hills. And it connects points that have equal elevation using a contour line. So in other words, if I were, and I'm going to draw it on here, going around the bottom of Mount Trashmore and I'm staying at only 10 meters above sea level, it might look like that. And then when I go to 20 meters above sea level, it connects like this. And then I go to 30 and it goes up like this. Okay, so each line is telling me a certain elevation above sea level. Okay, so contour lines never cross one another because you can't be at two different elevations at the same time. If they're super close, then the elevation is changing quickly, so it is steep. They close around hills with no numbers, like the one I just did. Mount Trashmore would be a hill. It wouldn't really have any numbers because it's very small. So this is what a hill would look like. If they have hatcher lines, like the ones I'm drawing in right now, this shows you that it is a depression or a hole, a canyon of some kind. It's going inward. Okay, and then it says if they cross a valley or a stream, the V points upstream. So let me try to draw one really quickly. If I had this little mini, let's say that this is a small mountain, and this river is running across it like this. These are the V's. Where it crosses the contour lines, you can see these little V's right here. Well, the V's always point upstream, so we would say that the upstream is pointing south and west. So the river is pointing north and east. And I know right away people think, well, it can't go north. But it can go north in the sense that it can travel from Virginia Beach to Norfolk, you know, in a northern direction. No, it cannot go uphill. But anyways, in this is probably not the greatest example, but in the example, we'll practice this in class. You look for the V's, that shows you upstream, and you say it's flowing in the opposite direction. Okay, so let's go on. This is a contour map as it's drawn, and this shows you, you know, at least two-dimensionally that you are moving upwards. Another example, you're going to build one of these in class. We're going to skip these. We will go over them in class. We're going to skip those. The Mercado projection shows the shapes of the land masses correctly, but the area is distorted. If you look down here at Greenland, I'm sorry, not Greenland, Antarctica and Greenland too, they're exaggerated a lot. As you get close to the poles, they have to try to stretch that area onto a flat surface, and they end up over-exaggerating it. Okay, a conic projection is made by projecting points and lines from a globe onto a cone. this would be used for pilots. So it says very little distortion of the area or the shape. It's used for road maps, smaller areas, because it can be detailed. Okay, and that's all of your notes. Make sure you take all of your notes and bring them to class. We're going to be doing lots of hands-on and lots of different practice to get you good at mapping. Okay, see you next class.